Good morning, thanks for joining. So it looks like it is working this time. If any of you were trying to see our last webinar, you would know that it did not air, but looks like we're good to go for this one. So today we're going to be discussing 3D printing on the production floor, but more specifically, how do you identify those applications for higher strength materials? So now that we're making a shift away from, I wouldn't say away from, but in addition to prototyping with additive manufacturing, more and more companies are using parts within production, whether that be end-use parts, brackets, tooling, or fixtures. There's many applications that you might not even think of when you think 3D printing, and we're going to discuss those today. How to identify them, and then also how to, measure the value. So the key takeaways from this presentation are when you leave, hopefully you're going to have a better idea of identifying these challenges within your own production line, choosing a benchmark or a specific application that you think is representative of the tools that you use, and then building an ROI based off of this benchmark to help evaluate a use case. So why manufacturing? Why are we making this shift from prototyping into production? Well, there's a couple of reasons for this, but it's mainly within the materials. So previously with 3D printing plastics, most of those materials are great when it comes to how they look, but they're not going to hold up in a real world, real use application. With MARKFORGED, we're able to print parts that are as strong as something like a 6061 aluminum off of a very similar technology to any other FDM printer, with the addition of continuous carbon or other composite reinforcements. So this means that you're able to print the tools and fixtures that you're currently machining and many other applications that we're going to discuss here today. So just as an overview, if you take a look at an X-ray view of a MARKFORGED 3D printed part, you're going to see these continuous fibers that are running either along the perimeter or isotropic back and forth. Those are determined in the software based off of the application and in which axis that you need the most amount of strength. But it acts as a rebar in the concrete, let's say, of your part, or as the skeleton that really supports that structure of your part. And most of the strength, as you can see here, is coming from those reinforcing fibers. So carbon fiber is much stronger than something like a 6061 aluminum. So when you're impregnating those fibers within your onyx part, you're going to benefit from the strength of those fibers more so than you are that base thermoplastic. So just a sort of a brief overview of some of the things that we're going to be looking at today are things like end-of-arm tooling on robotics, lathe tools or tools that you're using on your CNC machines, and inspection fixtures. These are some of the best applications that we've seen, at least for our lineup. So who are you going to talk to in order to get this information? So starting from the plant manager looking down on the engineering side, these are the people that in tooling and process engineering are best going to know what the inefficiencies in your line are. So they'll know exactly sort of where there's bottlenecks and where there are areas that need improvement. Operators and line supervisors are sort of on the front lines of knowing where these common issues are arising, and they'll know exactly what problems they're dealing with day to day that you can take a look at as a potential application. On the maintenance side, they know which parts are getting replaced most often and which ones are breaking more frequently than they should. And then quality assurance, they're the ones that are really affected because part quality is affected and impacted very greatly by the tooling that they're provided. So you're able to look at sort of applications and where to identify them through three separate lenses, mainly pain points and cost drivers, manufacturing applications, and then common tooling and fixturing materials. So we'll delve into pain points and cost drivers first because it's usually the easiest place to start. And you want to ask yourself, what is the time, the labor, cost that you're spending on parts right now, and how does that affect your productivity? So if you have, let's say, unplanned downtime, a part breaks, and you have to either outsource one or get one machined, what does that downtime cost you? And how often does that typically happen? And what can we do to mitigate that? So if you're in a production line for something like automotive, in an automotive industry making cars, every hour or every minute has a very high value dollar impact. Every minute that you're not making cars, you're losing out on business. So production stoppages quickly build up into a substantial lost revenue, and this is often a great opportunity for being able to quickly replace critical parts um, that are highly complex, that might take weeks, or even if it's just a week to shop out somewhere else or a couple hours in the machine shop. If you're able to print these overnight and have a stockpile of them, typically the time that you save in unplanned downtime um, is a significant number. So line changeover as well. If you're making lots of one part on a production line, but then you have to recalibrate for a different model or different part, there's time that it takes to recalibrate this line for this new configuration. So if you're able to have calibration jigs and fixtures that help you in this process, they can take something that might take a full day or even a week for a full line changeover and bring it down to a couple hours. And that time savings is huge. And then aftermarket upgrades and brackets. So often with sensors and new types of inspection equipment that you're adding to your lineup, the machines that you have right now, you're not replacing the whole machine to get this added capability. You're instead installing sort of an aftermarket sensor, which comes with its own bracketry that you have to design essentially for your machining process. So if you're able to print custom brackets as opposed to machining them, you're not spending lots of time creating these, as you can see here in this picture, that white part in the background, custom brackets that would normally take maybe a day or even a few hours to machine. It's a type of part that your machinist could be working on something else that's of a higher value. But you're able to essentially retrofit your line, your machine line, with new equipment at a much easier way than either buying aftermarket brackets or custom machining your own. And then lastly, within cardboard engineering, or duct tape engineering as they call it, these are temporary fixes that never really got a permanent solution. So something like this, which would be embarrassing to show someone on your production line, but it's essentially the machine here on the left is about a half an inch shorter than the machine on the right, and product moves from the left side to the right side. So this compressed air tube is there essentially to blow the parts up about a half an inch from the left to the right. And then every time you do a changeover from one line to another, or you're running a different product, or even if this gets bumped ever so slightly, you're gonna have to do lots of tweaking and calibration just to get this right. Which it could be that you just print a custom fixture or a custom jig for this application, so that every time you do a changeover, you're not having to tweak this. And so essentially any place that you see zip ties, duct tape, adhesives, those are all great applications for printing a very quick custom tool. So here are some questions that you can ask yourself to help identify some of these. So what areas in my processes are costing me the most? What are your biggest causes of loss, waste, unnecessary manufacturing costs? What is broken and replaced often? And then how much does it cost when it does? And when you're taking a look at that cost, is it not just the cost of the actual part itself, but how much is it costing in your unplanned downtime? And then what parts do you absolutely need to stay running? Which are the most critical? And then are there areas that you have temporary fixes for that you can have a more permanent solution that's more documented? And then these are the people that you're asking these questions to. You're talking to your plant manager, your manufacturing supervisors, your production supervisors, maintenance, and even the machine operators that might be doing these temporary fixes day to day. So the next lens that we're going to be going through is easily identifiable manufacturing applications. So these are sort of the easiest ones to see because they're things that you're making right now. But now you have the capability of making them faster, cheaper, and often a lot more complex. So anything that helps with machine setup, fixturing, positioning, and tooling, and then line optimization. So first we'll go through tooling and work holdings. So for mills and lathes, instead of machining your soft jaws out of an aluminum, you're able to now print those. You can get more customized shapes without an added cost to complexity. They are non-marring, which is also saves time on polishing the metals after you cut them. And then they're often a lot faster and less expensive than machining, because once you start the thing, you don't have to sit there and watch it. If you're paying a machinist to create your tools, they have to essentially sit there and work on it when they could be spending time instead working on more valuable parts, and machining more valuable parts that actually bring money into the business. So here's one of the more complex soft jaws off of a mill that we can do. And then also end of arm tooling. So most robotic arms have very customized end of arm tooling to pick up the exact part on your production line. So they're designed specifically for that part. As an example, this is a coupling from Dixon Valve that we 3D printed all of the end effectors there on the robotic line on the top that you can see. So the three custom grippers here that would normally cost several $100s each to machine, and if you're outsourcing those, it might take several weeks to get them back. And they have many different products on their line, so every time that they wanted to do a changeover, they were having to make these new quick change jaws since they were trying to make a faster tooling change environment. So instead of getting all of these shopped out and it costing thousands and thousands of dollars, they can print them at a couple bucks each and they can get them next day. Here's another example here. It's an end of arm tool that has vacuum suctions running through it. It picks up unfolded cardboard, but we're able to have channels that run through it to save on tubing to make a less complex part that would be otherwise almost impossible to machine. But you're able to print it very cheaply, typically within a day. So you can give it a try here. We'll take a look at this picture and see what potential applications you can identify just from this quick glance at a production line. Cool, and now we'll go through and I'll talk about the ones that I see first. So right off the bat, we've got robotic end of arm tooling, sort of like we've been talking about. Custom grippers that are made to pick up that specific part. We've got brackets for routing cables here. So often if you're gonna have these cables going across and you want custom configuration for them, you're able to print highly complex and customized brackets to fit your specific need. We've also got cradles and nests for holding parts in place, and also hold down clamps, all of which are configured specifically for that part that you're making. And the next place that we can look is in the inspection room. So every quality control, quality assurance room has inspection fixtures, and some of them are more complex than others, but essentially the easier they are to use and to position, the quicker and the more accurate your inspection is going to be. So 3D printing these are often way cheaper than it is to machine, because you can get highly complex shapes that conform specifically to the geometry of your part. So you can even have one of these in the inspection room, and your QA, QC team doesn't need experience with machining or having a CNC in-house even. And here's another fixture that we've made here. It's the same part, that same GE jet nozzle, but it locates and keeps the part in place so that it can do laser marking. But it's a quick, cheap, and a very easy to make solution when, if you had to machine this part, it might get very low priority in the machine shop. And then custom tooling as well. So this is a lathe bar puller off of a CNC lathe. Just a part that it might add or might save you a lot of time, but if you wanted to get this machined and you only need one of them, it's going to get very low priority either in-house, or you're going to have a hard time shopping it out if you're just making one. So it automates production on your lathes just without having a bar feeder, and then it enables small job shops to complete lower cost jobs, so you don't have to turn down as many jobs because of how long it takes, or how expensive it takes for you to tool your shop. You can go through many iterations as well. So let's say you're shopping these parts out to someone else. If you're going through many different iterations that you want to try, or if you want to have different sizes, it's a lot easier to do that in-house on a 3D printer, and you can do those quickly back to back and test them, as opposed to waiting a few weeks every single time you want to do a new iteration. So just as an example for this, it's a $13 part that replaces something that might cost you, upwards of $1,000. It's fully customizable, so you don't have to get some off-the-shelf thing. It's exactly conformed to your specific application, and it's easily replaceable. So if it breaks, you can print another one in a few hours, and you have to wait for either your internal machine shop or someone else to make it for you. And then these are some questions to ask yourself. So, where do you use the most fixturing and work holding in your processes? In your inspection room, if you have one, how do they get their current fixtures, and how do they currently fixture parts? Are they spending a lot of time setting up sort of like a series of clamps when they could just have one part that they pop the part into? Do you assemble in-house, or do you build your own assembly fixtures? And then how much does it cost out of house if you make all this stuff shopping out, as opposed to making them in-house? And how long does that take as well? And here are the people that you're going to be asking those questions to: your production engineers, your manufacturing engineers, your maintenance team, and of course your QA team. And then lastly, these are the materials that you're using within tooling and fixturing that you can just do a one-to-one replacement over. So like I said before, you're going to get very similar strength to a 6061 aluminum if you're using a composite fiber, continuous composite fibers. So you're able to replace a lot of those parts that you're making out of aluminum now, just one-to-one replacement to these processes. With things like tool steel, stainless steel, and carbide, you can get those material properties often and strength, but you're going to use inserts to get there. And often that's very easy to do. You would design in a channel for, let's say, a bracket that is made out of stainless steel or tool steel, and you can do an insert halfway through your print, and then it can print over that insert, and you get the added strength of that steel, or the wear surface of that steel, if it's a gripper, let's say, without having to machine that entire block. And then with plastics, anything that you're making out of Delrin right now, or nylon, you're able to replace those very easily with these materials. Just as an example, here's a Delrin block that you can, instead of machining that Delrin out, you can print it overnight. So one of the MARKFORGED customers, Aero Global, is replacing these aluminum and steel drill jigs with nylon with fiberglass. So it's tougher, it's abrasion resistant, it doesn't mar your parts, and you can go through multiple iterations very fast with very cheap production costs. So you want to ask yourself, where are you using your nylons, your Delrins right now in your plant, and where? If you're using aluminum or even tool steels and stainless steels, where are you using those? And then do they actually need to be these materials, or do they just need maybe a small part that has that wear surface capability? Or are they just the materials that you had readily available at the time, and could you get away with using something like composites? And then how long does it take for you to turn around these parts and these above materials if you're doing it in-house or shopping it out? And then what impact would it have on your business if you're able to get those parts in a 1 to 2 day turnaround, as opposed to if you're shopping it out maybe 2 weeks, or if you're making it in-house a week or so. And then these are the people that you're asking these questions to: production engineers, manufacturing engineers, and maintenance teams. So if you don't know where to start, feel free to use this as a resource. We've got a team of applications engineers here that they do this day in and day out. Their job is identifying areas of improvement and testing different applications to see what works best. So set up a call with us. We can discuss your processes over the phone, and we can even come out and walk the line with you guys to help identify some of these processes. And just a little bit about MARKFORGED. We're not just printing with composites, but we're also printing with metals. They've got a very strong and powerful slicing software that makes new technology like continuous fiber reinforcement very easy to pick up. And then the materials, like I said, they've got great surface finish on that bottom right. That is how the part comes off the machine, which is sort of unseen for FDM style printing, but they're also incredibly strong. So if you've got any questions that I don't get to at the end of this, I'm going to pull up the questions here in a minute. Feel free to email me at evan@neometricstech.com, or just give me a call, 407-988-7101. So now I'm going to give a look over to our questions. All right. I'll give a minute or two to see if any roll in, but if not, like I said, just jot down my email and reach out to me at a later date. If you come across an application that you're not sure if it's a good fit, feel free to send it over to me and we can discuss it. We can go over it with our team, see if it's something that makes sense, or even if it's something that you think needs some redesign, we can give you some talking points there. All right, doesn't look like anything's coming through. We try to do these, let's say, every other week or so, either within 3D printing or 3D scanning. So if you are interested in learning more, we hope these are helpful. And you can look forward, maybe we've got a lot of holidays coming up, but there's likely to be one in December. So keep an eye out for that. In the meanwhile, feel free to give me a call, or if you think of anything else, just shoot me an email. Thanks.